Numerical Methods Problem 16.23. A total charge Q is uniformly distributed around a ring-shaped conductor with a radius A. A charge Q is located at a distance x from the center of the ring, figure P16.23, which basically shows a ring and then A points to about the center of the ring, and then you have a charge Q that is x meters away from that center, approximate center of that ring. So the force exerted on the charge by the ring is given by this force equation, which is 1 over 4 pi times E sub 0 times QQX over x squared plus a squared to the 3 over 2, where E sub 0 is equal to 8.85 times 10 to the negative 12 c squared over Newton meters squared. Q equals big Q, which equals 2 times 10 to the negative 5th c, and A equals 0.9 meters. Determine the distance x where the force is maximum. So here are variables given to us by the equation. Here's a range for x, so we can plot up the equation. Here is our equation, or the constant part of our equation, and then we substitute our constant part of the equation into the rest of the equation here. Just another way to rewrite this equation here, basically. And so then we plot up our equation here, and we have to find the maximum point. So we have to use an algorithm to find the maximum point. And I decided to use the golden ratio algorithm again, or the golden section search algorithm. So we get our golden ratio, set up our lower and upper bound, set up our other variables, then we have a loop that checks our constraints. Then we plot up our approximation in red and green. So let's plot it up. In blue, you can see our equation of the, and green and red, you can see our approximation to the maximum point in this equation. And over here, we can see that our lower guess and our upper guess are the same. At about 0.4025 meters, we have a maximum of 7.8820 times 10 to the negative 15th force acting upon that charge Q. And that's it for problem 16.23.